You see here, for any function, domain and range, how to find. This is what our concept. Domain means what are the input values we will be giving to that functions line. Okay, what are the input values we are giving to the function? For example, you see, my dear students, we have here find the domain of right. Domain of number one. I'm having here f of x is equal to number one x square plus x plus 1. We are having like this, x square plus x plus 1, like this. For this problem, what are the input values you can supply? What are the input values you can give to that? That means what are the input possible values you can give it to that such that you will get a finite value as output. The range has some finite value. That is what our problem. Here, the input values, any value you can give to that such that this function is defined perfectly. You can give any value to that such that this function is defined perfectly. Therefore, see on f of x is equal to x square plus x plus 1. What we have here, this, right? Okay, the domain of f of x. You see on domain of f of x, anything you can do. Okay, is equal to what? Set of all real numbers is what the domain. What, right? The domain of f of x is nothing but set of all real numbers. Because anything you can do, f of 1 you can do 1 square plus 1 plus 1. That is nothing but 3. F of 2, that is nothing but 2 square plus 2 plus 1, like this. 4 plus 3, 7. Like this, you can do many values for this. Therefore, the domain of f of x square plus x plus 1 is nothing but right, a set of all real numbers we are having here. Next, one more problem. If we take find the domain of f of x is equal to 1 by x, right? We need to find domain of this function. F of x is equal to 1 by x. How we are going to find the domain of f of x is equal to 1 by x? Means, my dear students, if you see here, if I take 0, the denominator, if I take here 1 by 0, that becomes undefined. Therefore, you see here, if I take except 0, any value you can take, the function becomes defined perfectly. Therefore, you see, my dear students, what we are having is, okay, if I take x equal to 0, this function becomes undefined. For remaining any value, it becomes defined. Therefore, the domain means input values, what we are going to do. Domain of f of x is nothing but r minus 0, like this. R minus 0. Okay, domain of f of x is nothing but r minus 0. Here like this. Why means for x equal to 0, this become undefined. That's why the domain of f of x is nothing but r minus of 0, like this. Right, my dear students? Next, one more problem. If we take find the domain of f of x is equal to, suppose you have here 1 by 2x plus 1 or something like this. What is the domain of this means? Here, the denominator should not be 0. Here, the denominator should not be 0. Okay. If it is 0, 1 by 0 becomes undefined. 1 by 0 becomes undefined. That's why here let us make 2x plus 1 equal to 0. Then what you will get, x equal to minus 1 by 2. Therefore, the domain of f of x is nothing but r minus 1 by 2, like this. Domain of f of x is nothing but r minus 1 by 2. Such a beautiful way we are getting this particular problem. Right, my dear students? Here you see here, if I take x equal to minus 1 by 2, the denominator becomes 0. Right? The denominator is 0 means, okay, 1 by 0 becomes undefined. Once it is undefined, we will not get any finite value. That's why we are taking out that particular value and we are taking okay, the remaining values as the input values. That's why domain of f of x is nothing but r minus 1 by 2. Now here. Like that, we are going to do some other interesting problems, right, my dear students? Suppose if we have some other problem, something like right, what is the domain of they are given like this?
Sir, explain third problem again, sir.
What is the domain of f of x is equal to? We have here f of x is equal to here. What we have here is x square plus 1, x square plus 1 by, right? X square minus 3x plus 2, right? X square plus 1 by x square minus 3x plus 2. This problem. What will be the domain of this? Means, see my dear students, x square plus 1 by x square minus 3x plus 2. Here also the numerator become always positive for any real number you give. Now for the denominator, we have here x square minus 3x plus 2. This should not be 0. Okay, this should not be 0 means we have to take out those x values. That means if I take like this, x square minus 3x plus 2 equal to 0. If I take like this, then what I am going to get is x square minus 2x minus x plus 2 is equal to 0. We have here x minus 2 minus 1 if we take x minus 2 equal to 0. Now x minus 2 into x minus 1 is equal to 0. That means x is equal to 1 comma 2 like this. X equal to what? 1 comma 2. We have here like this. You see my dear students, x equal to 1 comma 2. Okay, fine. You see here what we have to do the factorization x is equal to 1 comma 2 on here. That means for 1 and 2 the denominator becomes 0. If it is 0, output value become undefined. The output value become undefined. That's why my dear students, okay, what we need to have the domain of f of x here. Domain of f of x, right now, domain of f of x is equal to r minus of 1 comma 2. R minus of 1 comma 2. I think it is right.
Sir, can you turn the board back?
Move camera back, sir.
See, this is what we have here, like this, my dear student. Domain of f of x here I am writing because I think it will not be appearing to you.
Sir, move your camera back.
Okay, it will not be appearing maybe to you. This what we are going to have the domain here I am writing. Okay, the domain is nothing but r minus of 1 comma 2. This is what we are getting, right? What are the input values you are giving? Okay, such that the output values becomes defined perfectly. That is what you call the domain. Okay, Nana? Please understand that I am going to do some other interesting problems on these domains, right? Some other interesting problems on these domains we are going to do. Now, you see, my dear friends, please observe. Right, next we are going to do some other interesting problems, Nana. Right. Next problems, what we have here is, right, that's nice. We have some other interesting problems here. We are going to discuss those domain problems, right? Now you see, Nana, we have one more different kinds of problems here. We have here, so for example, the fifth one they have given here. The fifth one is here, f of x is equal to 2x plus 3. 2x plus 3 by x square minus x plus 1, like this. This is what we have here. What will be the domain of this function, like this? Here you see, my dear student, 2x plus 3. Okay, numerator, it can be 0 also, no problem. But denominator, we are having x square minus x plus 1. What is the nature of the roots of this quadratic equation? Okay, if you find the discriminant b equal to b square minus 4ac, that is now minus 1 whole square, b b square minus 4ac, 4 into 1 into 1, like this. This is nothing but 1 minus 4, that is minus 3, that is less than 0. That implies the roots are imaginary. See here, the roots are imaginary. Right? For this, the roots are imaginary. Once the roots are imaginary means, my dear students, you know that okay, the sign of this quadratic expression here, a value equal to 1, which is positive, and b is less than 0. We have discussed in the quadratic concept, quadratic equations concept. The sign of the quadratic expression, if a is positive and b is less than 0, then x square minus x plus 1 is always positive, which is the sign of this is same as the sign of a. Therefore, see, whatever real number you substitute here, you are going to get this as positive. Whatever real number you substitute in the denominator, you are going to get this as positive. That means what we have is the domain, right? Dear students, you see here what we have here, the domain of f of x, that is equal to x square minus x plus 1 is set of all real numbers. Because whatever value you do here, what you are going to get is right. It is positive. Therefore, any real number you can do for that. Therefore, the input values what you are giving is set of all real numbers you can give to this particular problem. Right, my dear students? This is one thing we have here. Now let us go to discuss one more problem. What is the domain of next different types of problems we are going to discuss? F of x equal to square root of 2 minus x. This is what we have here. F of x is equal to square root of 2 minus x. Okay, what will be the domain of this means? My dear students, you see here the values of x. What we have to get is here 2 minus x. This 2 minus x within the square root, that has to be greater than or equal to 0, because within the square root you are having here that is the numerator, that should be 2 minus x should be greater than or equal to 0, right? Once this is 2 minus x is greater than or equal to 0, we know that we can write this as minus of x minus 2 is greater than or equal to 0. Minus of x minus 2 is greater than or equal to 0. How? By multiplying, right? By multiplying with minus sign, right? You know that by multiplying with the minus sign, you are going to get with the minus sign. What you are going to get is x minus 2 is lesser than or equal to 0, because whenever we multiply with negative sign, the inequality will be reversed. That's why x minus 2 is lesser than or equal to 0 we have here. That means x is lesser than or equal to 2. That means x belongs to minus infinity to 2, like this. Minus infinity, comma. Okay, this is closed interval. This is what the domain of f of x when we have square root of 2 minus x means. Okay, the domain is nothing but open interval minus infinity, comma 2, like this. Right, my dear students, such a wonderful problem is. Okay, we are going to discuss one more problem, as many problems as. Okay, here is the domain is what we would like to get is first of all that is under the square root. It should be greater than or equal to 0. That means we have here 2 minus x is greater than or equal to 0 means to take minus of x minus 2 is greater than or equal to 0. That means by multiplying with minus sign, we have here x minus 2 is lesser than or equal to 0. Like this. That means x is lesser than or equal to 2. That means x belongs to minus infinity, comma 2, like this. Right, my dear students? That is what the domain of f of x equal to square root of 2 minus x. What are the possible x values you can supply such that you are going to get finite values nothing but x belongs to minus infinity, comma 2. Right? Next, one more problem we will do here. See, my dear students, here some space is there. We use this space to do. Right. One more thing here. Okay. They have given once again see here, for example, what is the domain of f of x equal to square root of x minus 2. Here x minus 2 has to be greater than or equal to 0, because under the square root you should not have negative values. You should have only logic 2 or 0 in the numerator. Therefore, it is very simple. X is greater than or equal to 2. That implies x belongs to closed interval 2 to infinity. Okay, my dear students, x belongs to closed interval 2 to infinity. This is what the domain. This is equal to the domain what we have. Wonderful. This is what about the seventh problem, my dear students, what we have here. And one more problem here. Suppose if I take, okay, what is the domain of f of x equal to 1 by square root of x minus 2? Suppose if I have like this, what will be the domain? Since it is in the denominator, it should not be 0. X should not be 0. Whereas if it is in the numerator, means we included 0. But we should not include 0. That's why x minus 2 has to be greater than 0. Not equal to 0. Why means? Because it is in the denominator. In the denominator, if it is 0, then 1 by 0 becomes undefined. That's why whenever it is in the denominator, we are not going to include 0. If it is in the numerator, yeah, this is something like this. It is in the numerator, we can include that x minus 2 is greater than or equal to 0, no problem. X is greater than or equal to 2. X belongs to 2 to infinity, that is what the domain we have here. Therefore, here, my dear students, what we have here, x is greater than 2 is what our values. That means what we have, x belongs to open interval 2 to infinity is what our specified domain. Such a beautiful way we have got, my dear students, please observe, right? This is what the domain we did from different types of problems. Please observe, we will go into some other problems very nicely, right, my dear students? Please observe, Nana. Okay, my dear students. Right. Next, we are going to do some other interesting problems on these domains, right, in today's class. Yeah, very good. Navesri, understood? Very good. Nice. Fine.
Understood, sir.
Now, domains of different functions. That is what we are doing here. Right? Now see, Nana, what we have here, the other type of problems, what we have here, we did it. Now, right? Okay, fine. Now, the ninth problem we do here, right? We have here f of x is equal to, suppose, square root of x square minus 4. How will you find the domain of this, right? X square, square root of x square minus 4. How will you find the domain of this? Here also, my dear students, what we have to do is, the domain we require means x square minus 4 has to be greater than or equal to 0, like this, right? Because it is the numerator. And you know that how to do this x square minus 4. 4 you can write as 2 square. That is greater than or equal to 0. Now this, you know, x minus 2 into x plus 2 greater than or equal to 0. And you know that quadratic inequality concept. You are going to use quadratic inequality concept, that is nothing but one is minus 2 and another one is plus 2. From minus infinity to plus infinity we have here. And you know that here it is greater than 0, less than 0, greater than 0. Therefore, x belongs to here. X belongs to what you are going to have? Minus infinity comma minus 2 union, right, my dear friends? And the 2 to infinity. But we have here greater than or equal to 0. That's why this 2 we will include. This 2 what we will do, minus 2 and 2 will be included. This is what the domain of this particular problem, ninth problem. Right, my dear students? This is the way how we did it. Suppose we have the same thing. Now the 10th one, find the domain of one more problem we have here. For example, we have here f of x is equal to 1 by square root of 4 minus x square. We have like this. How we will be finding this particular problem, right? Dear students, how we are going to do this particular problem is f of x equal to 1 by square root of 4 minus x square means here it is in the denominator. That means this 4 minus x square, 4 minus x square has to be greater than 0. 4 minus x square, that has to be greater than 0. Why means it should not be 0 in the denominator. Okay, that's why 4 minus x square is greater than 0. That means what we do now, we will take minus sign common, then x square minus 4 is greater than 0. We multiply by minus sign because inequalities problem. We multiply by minus sign, then what we will get is x square minus 4 is less than 0. We are going to. That means x minus 2 into x plus 2 is less than 0. What are the x values we are going to get? This is now quadratic inequality. Once again, minus infinity to plus infinity. This is minus 2 and 2 less than 0. This is greater than 0. This is less than 0. This is greater than 0. We need less than 0. Therefore, x belongs to minus 2 comma 2. We are going to get. This is what the domain. Domain means, I told you already, Nana, what are the x values you are going to supply to that function. Those are what? Please observe, these are some different kinds of problems which you are having, my dear students. Right? Wonderful. Like this, you will do, my dear students, you can do subjective problem set 2. All problems I have written. Okay, many things here. Right? Very good. Please go through and observe these problems. Right? Okay, my dear students, next we have some other interesting problems on the way to us. We are going to this is what the way how we will do the domain of these problems, right? Wonderful. Next we have, my dear students, there are some interesting problems in our the way. You see, Nana, how we are going to do these problems. Already operations on functions problems I explained in the recorded video to you, right, Nana? Now we are having some other kind of interesting problems here. This is now to convey this problem. A function, if the function f is a function from real numbers to real numbers, we are having here and defined by f of x. See here, f of x is equal to, you are having here 3 power x plus 3 power minus x by 2 like this. Then show that, okay, they're asking you to show that. Now, see, Nana, show that like this. What we have here is f of x plus y plus f of x minus y like this. F of x plus y plus f of x minus y is equal to 2 times of f of x into f of y. This is a nice problem, my dear students. We will discuss now how to do this particular interesting problem, right? See, my dear students, it's very important. Many times they have asked even in competitive exams, JEE mains and BITSAT like that. See, Nana, how we will do is let us take left hand side. We need to find this. Okay, for finding left hand side, let us find first f of x plus y. F of x plus y means what, Nana? Wherever x is there, you are going to replace x plus y. That means f of x is this, Nana. That means you are going to replace x by x plus y. That means 3 power x plus y plus 3 power minus of x plus y 4 by 2. You are having like this. And this, of course, by dear students, we can easily write 3 power x plus y. We can write as 3 power x into 3 power y. Right? plus this also 3 power minus x into 3 power minus y whole by 2. You can write like this. Fine. Next, what we have here is f of x minus y. F of x minus y means wherever x is there, we can replace by x minus y. That means 3 power x minus y plus 3 power minus of x minus y by 2, like this. Now we see now this is equal to, we have here 3 power x into 3 power minus y by plus, right? Here 3 power minus x. 3 power minus x minus into minus plus. It is now 3 power y by 2, like this. This is what we have here now. Now left hand side is what actually? Left hand side now we have here f of x plus y plus f of x minus y. This is equal to, you are going to get, right? Okay, f of x plus y is this 3 power x into 3 power y plus, right? 3 power minus x into 3 power minus y by 2. Okay, since 2 is the LCM for all these things, we can write commonly 2 like this. And here this is f of x minus y. Now here 3 power x into 3 power minus y plus 3 power minus x into 3 power y. This is what left hand side we have what, my dear students. Now if you take the right hand side part, right? 2 into f of x into f of y, 2 into f of x into f of y. How we are going to get this 2 into f of x? F of x is nothing but what? 3 power x plus 3 power minus x by 2 into 3 power, okay, y. That is nothing but 3 power y plus 3 power minus y by 2. 1, 2 and 1, 2 will be cancelled here. This is 2 here. Now we just multiply here. Okay. Yeah. Okay. Yeah. Just multiply this, Nana. You will be getting here. Okay. What we are going to get here 2 is what the LCM part we have here like this. Right. This is what 2 3 power x into 3 power y. That becomes 3 power x into 3 power y. Right. That is what one thing we have here. Next 3 power this with this, this with this. That means plus 3 power x into 3 power minus y. Now like this, plus next 3 power minus x into 3 power y. 3 power minus x into 3 power y plus 3 power minus x into 3 power minus y. 3 power minus x into 3 power minus y. Now this and this both are same. See here 3 power x into 3 power y, you have left hand side, here also you have here. Denominator by 2 by 2. 3 power minus x, 3 power minus y. Here also 3 power minus x, 3 power minus y. 3 power x into 3 power minus y. Here also 3 power minus x into 3 power y. 3 power minus x, 3 power y. Everything we have got perfectly. Therefore, my dear students, we proved this problem very nicely. Therefore, left hand side is equal to right hand side. Beautifully, we have got this problem. Just applying and expanding. That's all about this problem, my dear students. Next, we are going to do one more problem, very important, and that's very simple. Right, Nana? Have you understood? Very good. That's nice of you. Right. Very good. Next, we are going to do one more problem, my dear students. Yeah, raise it. Okay, good, good, Nana. Who understood? Please raise the hand. 3 participants, 5 only out of 51 students. 20. Wow, wonderful. Just multiplying, Nana. Just multiplying. Wonderful. 26, 30 should reach. 30. Right. That's fine, Nana. Very nice. 31. Wow, magical figure. That's nice of you, my dear friends. Next, okay, that's nice. Okay, now we are going to do one more interesting problem, Nana. You see how we are taking this very nice and okay, like that, little more problems even possible. Okay, we prepare one nice video to have more problems because it is the concept for the next coming Sunday also. Total functions will be having as exam for you. Okay, till Saturday, what we are going to discuss, those all we will include in this. Now you see, Nana, one more problem of this kind. We have that's nice of you, my dear students. See here, what is this problem number? 11. This is 12. Now, right. This is 12. We have here, this is given that f is a function from r minus 0 to r. Okay, the domain is r minus 0 to r, and they given that wonderfully f of x is equal to x plus 1 by x. And this. Then show that here also. Then show that. Okay, see now this problem will show that what we have is f square x is equal to f square x equal to f of x. F of x square plus f of 1 like this. F square x is equal to f of x square plus f of 1. See, Nana, this is also very nice. My students were able to do how beautifully we can do this problem. See, f of x equal to x plus 1 by x they given. We need f square of x. F square of x. That means, my dear friends, f square of x means, you know that I given from algebra of operations, f square x equal to f of x whole square, because I given already f power n of x. F power n of x is nothing but f of x whole power n, like this. Therefore, this is now f square of x is nothing but f of x whole square means x plus 1 by x whole square, like this. This is now what we have is x square plus 1 by x square, right? A square plus b square plus 2ab. 2ab means 2 into x into 1 by x. Now this becomes x square plus 1 by x square plus 2 now. Wonderful. This is what the left hand side part we have, my dear students. Very simple. Right? Now right hand side, we will take right hand side part. What is right hand side part? We have here f of x square plus f of 1. Let us do f of x square. F of x square means what now? Just you replace x by x square. Just you replace x by x square. See, f of x square. F of x is x plus 1 by x. F of x square means what now? Please try to say. F of x square means wherever x is there, you have to replace by x square. That is now x square plus 1 by x square. And f of 1. F of 1 means wherever x is there, you are going to replace by 1. That's why 1 plus 1 by 1. Wonderful. Now this is x square plus 1 by x square plus 1 plus 1. What is 1 plus 1? We have got 2. Therefore, see now, we have got this problem. Left hand side, we have got x square plus 1 by x square plus 2. And also the right hand side, what we have got x square plus 1 by x square plus 2. Therefore, left hand side is equal to the right hand side problem. Such a beautiful way we have got this problem also, right? Wonderful, Nana. See how nicely we have got this particular problem, right? Please go through, right? Okay, fine. Have you understood, Nana? Please raise the hand. This problem. How many of you have understood this problem? 16, 17, 20, 22, 24. Okay, very nice. 30. You should cross 30 and 40 like that. Right? This is a nice problem like this we'll be doing, my dear students here. Right? Fine. Let us do, if time permits, one more problem. Okay, interesting problem we will do. Right? Okay, prepare well and do the problems, homework problems. Okay, you can do from there are some different types of functions. I will explain these functions in a video. Nice video I will explain to you. Okay, subjective problem set 1 we did already. Subjective problem set 2. Right? These are different types of functions are there. That is all we will discuss. Okay, Nana. Subjective problem set 2. You can complete, Nana. Domains problems I have explained to you. Right? Domains problems I have explained to you. Now they have given one more problem. Find the domain. We have a short time. Okay, only 2 minutes time is there. I am going to explain it. There are some problems. Right? Here, find the domain of. See here, my dear students. Okay, I am erasing this part. f of x is equal to the 13th one. Find the domain of, right? Find the domain of, right? F of x is equal to log to the base, okay, mod x. This is what is domain of log of mod x? You know that log will take only positive numbers, right? Here it is given that log of mod x. Since mod x is there, okay, and you know that logarithms are not defined for 0, right? Therefore, see, log 0 is not defined, and any value except 0 it is defined. Log 1 is 0. Therefore, here since we have mod x here, therefore the domain is equal to, okay, all real numbers except 0 I can give because mod x is there here like this. R minus 0 is what domain. Suppose we have one more thing here, domain of, we need domain of without f of x equal to without mod, only log x without modulus. Then how we are going to do this problem, my dear students? You know that logarithm is defined only for positive real numbers. Therefore, domain is equal to, in this case, what you are going to get is r plus set of all positive real numbers. That means 0 to infinity, open interval 0 to infinity. This is what the domain of f of x equal to log x, and here log of mod x, right? Mod x. When you have mod x, there is different. Without mod x, it is without mod x. This is with mod x. There is difference. Please observe, Nana. Please try to do the problems from your thing, and I will try to give more problems.